true projects. In this video, we are going to discuss about the project which is weed detection in agriculture and ensemble learning approach. So before getting into the execution, let me give you an overview of the project. So why detecting these weeds important? In farming, it is very important to keep these weeds under control to help crops grow well and also avoid losing money. So what are these weeds? Weeds are like unwanted plants in the fields and they grow alongside crops. And they steal water, sunlight, and nutrients from the crops, which makes it harder for crops to grow properly. So in the past, farmers they used chemicals called herbicides to kill these weeds. But these chemicals they make harm to the environment and also to the people. Plus, they even cost a lot of money. So, to solve this problem, we have come up with an automated weed detection system using advanced techniques like machine learning and computer vision to automatically find and identify weeds and cotton plants in fields. So, the author in the base paper, he has explored various machine learning models as well as deep convolutional neural network models. Coming to machine learning models, they include support vector machine decision trees. And DCNN models are GoogleNet, AlexNet, Inception V3, Exception, and EfficientNet V3 for weed detection as well as cotton plant detection. He has also investigated hybrid models combining CNNs with traditional classifiers like support vector machine as well as CNN models which are trained on feature extraction followed by classification. So we have further improved weed detection system performance by using advanced ensemble techniques. One technique is voting classifier, which combines the strengths of multiple individual models. So in this project, we have combined decision trees and random forest to make accurate predictions. We also used another ensemble model, which combines the features from exception as well as efficient net B3. These two are the powerful models for analyzing images. So by combining these different approaches, we aim to make our weed detection system more accurate and also reliable, which helps in farmers to manage their crops better. And we evaluated all these models using accuracy, precision, recall, and FN score. So all these four are the error metrics which are used for evaluating all the classification models. So we used all these four metrics to evaluate all the models which are built in the project. So after evaluating, we found that voting classifier, it has performed well. That is, it performed the best, showing it's great for detecting both weeds as well as cotton plants accurately in agricultural fields. Moving on to implement this project, we need software and hardware requirements. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. And moving on to the hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. So moving on to the algorithms used, these are the algorithms which are built in our project. Here we have models which are in the base paper as well as which we have proposed. So here we have proposed voting classifier as well as exception, efficient at B3, which are ensemble models. So among all the models built, voting classifier, it has performed well. So let's understand what is this voting classifier. Voting classifier, it is an ensemble learning technique where predictions from multiple individual models they are combined to make a final prediction. Here we have combined decision trees and random forest. Each model detects wheat and cotton leaves on the input image, and the voting classifier it aggregates these predictions based on majority vote or a weighted combination of these individual predictions to make a final decision. Each model's prediction is treated as a vote. By leveraging the collective intelligence of multiple models, this voting classifier it aims to enhance the accuracy and robustness of weed and cotton leaves detection, potentially outperforming any single model alone. So now we will execute the project. To execute it, we have to open the code folder which contains source code files. So these are the source code files in the code folder of the project. Let's understand each file, how will they be used in the project. So here in the first folder, we have the data set. We have two subfolders in it. One is train and the other one is test. So let's see what is in train folder. So here we have two subfolders. One is cotton and the other one is weed. So first let's see cotton folder. So here there are all the cotton leaf images. So we'll be using all these images to train the models. So here we have weed images. So we'll be using all these weed images to train the models. So we will combine both of these models and train the algorithms to detect cotton as well as weed. So now get back. Similarly, we have in test folder also, we can observe that there are cotton leaves as well as weed. So we use train folder to train all the models and test folder to test the models. That is how well the models have performed. So let's see. Here in cotton, we have 177 images and in weed, we have 113 images. In test, we have 24 images in cotton and in weed, we have 14 images. So here we have split the data set in the ratio of 80 for train and 20 for test. So let's come back. Here in the sample folder, we have test cases images. So here we have both the folders. One is for cotton and the other one is for wheat. So let's see the images of cotton. So we'll use these images as the test cases in the front end to detect the cotton leaf. And here in this folder, we have images of wheat. So we will use all these as test cases in the front end to detect wheat. So now get back. Moving on to the static folder. This folder contains files related to project styling and interactivity. They include CSS, JavaScript, and Bootstrap files. So these files, they are important for enhancing the visual appeal and the functionality of the project's web interface. And here we have templates folder, where we have all the HTML pages which are utilized in the project. And they are index.html, about.html, etc. And this each HTML file, they represent a different page of the website which provides the structure and the layout for displaying content to the users. Moving on to the app.py file. This is a Python file and this encompasses the front-end logic of the project. It handles server-side operations, including processing user requests, interacting with the database, and dynamically generating content to be presented in HTML templates. And these are the model files which contain the algorithm information and they will be loaded into the project code during runtime. And here we have notebook.ipynb file. These files contain information about the code. So this is a Jupyter notebook file which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, which makes a popular choice for the data science. And these two are also the model files. So these are all the model files. And this is the signup.db file. This file is a database file which is used to store the user information. Now we have to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we need to open the Anaconda prompt. Using the command cd followed by the space, we need to paste the copied path and then click on enter. So here we can observe that current directory is changed to the code folder's path. Now we have to compile app.py file. So give the command python space app.py and now click on enter. This command, it will execute the Python script and it will perform a runtime check for any syntax errors or logical issues. So after running the app.py file, Flash framework will host the application locally at the default address, which is the local host and the port unless configured differently. So this is the local host and this is the port. So now we have to copy this local link provided by the Flash framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome. So here we need to paste the link and then click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flash framework. So first we have to sign up. So click on sign up and enter all the registration details if we are registering newly. I have already registered and I have an account in it, so I'll directly sign in. And here we need to provide our username and the password. So give the username and the password to log in. We have logged in successfully and we are redirected to prediction page. So here we can see a choose file button. We need to click on that for uploading cotton leaf images as well as weeds. So click on choose file. So here we already have the cotton test cases from the sample folder. So I'm going to upload the first image. Here we can observe that image is loaded. Now upload it. So here we got the prediction for the uploaded image. So this is the uploaded image. And here we got the prediction as cotton leaf. We can observe that it has correctly predicted as cotton leaf. So we will try uploading some more images. Click on try again. Click on choose file. So this time we'll be uploading the last image. Click on open. Image is loaded. Now upload it. Here this is the uploaded image and here we got the prediction for the uploaded image as cotton leaf. So we will try using some more images. Click on try again. Click on choose file. So now we'll be uploading this image. Click on open. This is the uploaded image of cotton leaf and it has correctly predicted as cotton leaf. So we will try using one more image. Click on choose file. And now we'll be uploading the eighth image. Click on open and now upload it. So here we can observe that this is the uploaded image and here we got the prediction as cotton leaf. As of now, we did prediction for the cotton leaf. Now we will do prediction for wheat. So click on try again. Click on choose file. Now we have to upload images from the other folder, that is wheat folder. Open it. So we'll be uploading the first image. Click on open. We can observe that image is loaded. Now upload it. So this is the uploaded wheat image. And here we got the prediction as weed. It has correctly predicted as weed. So we will try using some more images. Click on try again. And now click on choose file. So now we will upload the third image. Click on open. So this is the uploaded image. And here we got the prediction as weed. So we will try using some more images. Click on try again. Click on choose file. So we will be uploading this image. Click on upload. So this is other type of weed. And here we got the prediction as weed. So let's try using some more images. Click on try again. Click on choose file. So let's upload the last image. Click on open and now upload it. So this is the uploaded weed image. Here we got the prediction correctly as weed. So we'll try using last image. Click on try again. Click on choose file. So we'll be uploading the seventh image. Click on open. So this is the uploaded image and this is different type of weed. And here we got the prediction as weed. So this is the weed in it. Here we can observe that weed is in green color. And the rest all is turned to black color. So we will try using some more images. Click on try again. Now we will try using cotton leaf images. So click on choose file. Get back to the cotton folder. So we will upload the third image. Sorry, second image. Click on open and now upload it. So this is the uploaded cotton leaf image and here except cotton leaf all other things are turned to black and brown and only the cotton leaf is in green color. An application made this and it has predicted as cotton leaf. So we'll try using some more images. Click on try again. Click on choose file. So we will upload the ninth image. So this is the uploaded image and here cotton is marked in green color and rest all land, soil and other weeds are in brown and black. And it has correctly predicted as cotton leaf. So we will try using one more weed image. Click on choose file. Get back to the weed folder. So we will upload the fifth image. So here, this is the uploaded weed image. Except weeds, everything is turned out to blue and black. And it has predicted as weed. Now we will see the graphs of the project. So click on graph link. So here we have accuracy and loss graph of exception and efficient B3. So this is loss graph and this is accuracy graph. Here on both the graphs on x-axis we have iteration and in loss graph and on y-axis we have loss and on accuracy graph on y-axis we have accuracy. Here Blue is training loss and orange is validation loss. And here, blue is training accuracy and orange is validation accuracy. Here we have accuracy comparison graph where on x-axis we have accuracy score of each algorithm and on y-axis we have algorithm names. So here we can observe that voting classifier is performing well than other models which have we proposed. So here we have precision score comparison graph. This is recall comparison graph and this is F1 score comparison graph. So we have executed our project and we have seen all the graphs of our project. So now click on sign out. In this way, just by uploading images to the system, it will detect whether it is weed or not. So by doing this project, farmers will benefit from predicting the weed. So they can take the preventive measures.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.